Welcome to Ask and Learn.
In this problem, we have stainless steel ball bearings leaving the oven at a specified uniform temperature and at a specified rate. They are exposed to air and cooled before they are dropped into water for quenching. We need to calculate the rate of heat transfer from the ball bearing to the air. Now, the density and the specific heat of the ball bearing material is given as rho. The density is equal to 8,085 kilogram per cubic meter, and the specific heat at constant pressure is 0.48 kg or kilojoules per kg degree Celsius. So for the closed system of the single ball bearing, we know that the energy in minus the energy out of the ball bearing must equal to the change in energy delta E for the system. Now, the energy is leaving the ball bearing, so we have a heat transfer out minus Q, and this is equal to a change in internal energy of the ball bearing delta U. And delta U can be written as M, so we divide it by M, or we bring out the M into U2 minus U1, the specific internal energies. And so this implies that if we multiply both sides by minus 1 and we expand the brackets, we get this is M times C, the specific heat, times T1 minus T2, the change in temperature. So now that's our energy balance equation. Now the first thing we do is calculate the total, the mass initially of one ball bearing and then the total heat transfer from a single ball bearing. So the mass of one ball is its density times its volume, rho times V. So that's rho times 4/3 pi r cubed, which is the volume of a sphere. But we have the diameter, so we can write it as pi d cubed by 6. And if we substitute our values in here, we get this to be 8,085 for rho multiplied by pi times the diameter of a single ball bearing is 0.012 meters, and that's cubed divided by 6. So we get the mass of a single ball bearing to be 0.007315 kg. Now, using the mass, we can put this into our energy balance equation, and we get the heat transfer out of a single ball bearing to be mc T1 minus T2, and now we have these values. So this is 0.007315 kgs times the specific heat of 0.48 kilojoule per kg degree Celsius into a change in temperature. The initial temperature is 900 degrees Celsius, and the final temperature before the ball bearings are quenched is 850 degrees Celsius. So we get the heat transfer, the heat lost by each ball to be 0.1756 kilojoules for each ball bearing. Now we want to calculate the rate of heat transfer from the ball to the air. So the total rate at which heat is lost to the air, Q dot dq dt, is equal to the rate at which the balls leave the oven, N dot, where N is the number of ball bearings, times Q out. This is the one we've calculated before. This is per ball. So this is equal to the number of balls leaving the oven, which is 800 per minute, multiplied by the energy transfer from one ball, which is 0.1756 kilojoules for every ball. Hence, we get the rate at which the ball bearings lose energy to the surrounding air is 140.5 kilojoules per minute. So if we convert this to seconds, we get this to be 2.34 kilowatts.